Hello, everyone, and welcome to the Math 3B podcast. My name is Greg Perkins. I'll be your host. So, we're going to practice some integration right here, and I'm looking at this and thinking I should use integration by parts. So that's a good method when you have two functions being multiplied, like an x squared times the sine of 2x. But how does that formula go? Well, luckily, I've got my friend right here, a 3x5 card to remind me. So when you're integrating a product, a u and a dv they're called, then it's going to be u times the v minus the integral of v times du. And basically the idea, or one of the ideas, is you're taking a harder integral and you're going to break it down into the u times v, and then hopefully this will be an easier integral. That's the idea anyway. Now, there's a couple of things we have to keep in mind. This could be the u and this could be the dv, or the order could switch. Because it's multiplication, you can switch the order. One of the guiding principles is whatever the u is, notice that its derivative goes right here. So if you can make the du be something that is simpler, that would be best. All right, so if I chose this to be the u, in other words, I let the u equal x squared, the derivative is 2x. And integrating a 2x is pretty easy. So I'm going to go for that. So I'm going to say, all right, start off by letting the u equal the x squared and the dv be the other part of it, which is sine of 2x. And I sometimes prefer to put the 2x in parentheses, times the dx. On this side, we need to take the derivative, and on this side, we need to integrate. So, taking the derivative, that's pretty easy. Du dx, or in other words, the derivative with respect to x, the derivative of x squared is 2x. Now, I need to do one more step here because I need all of the u information on the left and all the x's on the right. So I need this dx to move over to the right. So just multiply both sides by dx. Oh, you know what? I could even use my magic red pen and go dx times dx. And then these two cancel, and we get the same thing. To be honest with you, this step is exactly the same each and every time. And so quite often I'll just skip that step and just go from that step to the derivative step. Okay, so this is set up. The next thing to do is on this side, you integrate. So what's the antiderivative of sine? Well, little 3x5 card, what do you say? They say that the antiderivative of sine is negative cosine. And I can check that answer by taking the derivative of cosine, which is negative sine, and then that negative and the other negative will cancel, and it'll give you sine back, so it's true. Well, what about the integral of sine of 2x? Well, it's also going to be negative cosine. This time it would have 2x in here, and then you would need to divide by a 2. The reason you have to divide by a 2 is when you check your answer and take the derivative of this, eventually the chain rule is going to say you have to take the derivative of 2x, which will put a 2 on the outside, and the 2's will cancel. So this was a quick little review of Math 3A. Hopefully you've seen that before. So the antiderivative, or in other words v, will equal, so it's going to be negative cosine of 2x divided by 2. Now notice over here, the 3x5 card was reminding me, hey buddy, don't forget, you need to put a plus c at the end. And I'm like, yeah, I'll do that at the end. The very last step, see, the very last step, I'll put the plus c. But while I'm in the middle of the work, I don't want to put the plus c. Okay, now the formula is that it's the u times the v. So the u times the v means multiply on this diagonal. So it's going to be x squared times And I'm just going to take the negative sign and put it in front. Negative cosine of 2x divided by 2. All right, that's the u times the v. Next it goes minus the integral of the v times the du. So that means that it's these two down here. So the first one you multiply on the diagonal, and for the second part you multiply straight across. So that's going to be the 2x times, and again I'm going to just take the negative and put it in front, the cosine of 2x divided by 2. And then this dx, I'll just move it to the back part. Okay, so we now have a simpler integral. In fact, this could be cleaned up and simplified. So for example, if I get my magic red pen, I could have the 2's actually cancel. I could have the negatives cancel, which will make that a plus. So what I really have is negative x squared cosine of 2x, that part's not going to change, divided by 2, and then plus the integral of x times cosine of 2x, and the 2's canceled, so it's just this. So it turned our more difficult problem into a simpler one. And now something that quite often happens with integration by parts, not always, but it does happen at times, and that is I get to do the whole process over again. So this also needs to be done using integration by parts. When you do it multiple times, be consistent. I started by letting u equal the x squared part, and I let the dv be the trigonometry part, so be consistent. This is going to be the u, and this is going to be the dv. So the u is equal to just an x, and the dv is equal to cosine of 2x. On this side, take the derivative, and the derivative of x is just a 1. So like I said, this step right here is always the same, so I often just skip and go down to that part. So that's what I did. I multiplied the dx on that side, saves me one step. And then the antiderivative of cosine is just sine of 2x. And because of the chain rule, I need to divide by 2. If I was taking the derivative, I would multiply by 2. Since I'm doing the antiderivative, I divide by 2. All right, now we're almost done. So there's going to be the u times the v, so multiply this. So first of all, I should carry this stuff down. So there's negative x squared cosine of 2x divided by 2. Then there's the plus. And now there's the u times the v, so that's going to be x times sine of 2x divided by 2. And then there's going to be the integral of the du times the v, or the bottom row. And it has to go minus the integral of the du, so 1 times sine of 2x divided by 2. And now we're almost done. So we've got this done, we've got this done, we just need to integrate that one. So the final answer is going to have negative x squared cosine of 2x divided by 2 plus this middle one, and then finally the last part, find the antiderivative here. Well, the antiderivative for sine is going to be cosine with a negative, and so then the two negatives are going to cancel. This negative and that negative are going to cancel, and then it's going to be plus cosine of 2x divided by, now because of this, again, the chain rule is going to make me divide by 2, so that means it puts another 2 down here. So if you got two 2's, that's a 4. And then look at the little plus C, it's perfectly in place.